See this. Let's say these three are the groups given. Let me call it as G1, G2 and G3. The question is about finding out all the generators of each group G1, G2 and G3 one by one. Now let's try to find out the generators of G1, the group G1. Okay, so if you see the group 1, the number of elements are actually 6, right? So if you have 6 elements, then how many generators can be there? For that you are supposed to find out 5 of 6. In order to find out 5 of 6, you are supposed to find out S6. S6 is number of elements less than 6 which are relatively prime to 6. So all the elements 1, and then 2 is not relatively prime, 3 is not relatively prime, 4 is not relatively prime, 5. Only 1 5, which means you are supposed to have 2 generators for this group in case if it is cyclic. We are not yet sure that it is cyclic, but then in case if it would have been cyclic, then we are supposed to get 2. So why am I doing this? Because if you can find out at least one generator, you need not find out the others. If you find out at least one generator, let's call it as A, right? Then the way of finding out the other generators is A power 1 and A power 5. That's it. A power 1 is this and A power 5 is the other generator. Or one other way of finding the generators is find out a generator and find out its inverse. That inverse is also going to be a generator. But instead of that method, go with this. See, as of now, again, I am not sure that this particular group is cyclic. I am not sure. But in case if this would be a cyclic group, then it would have definitely 2 generators, right? So when will it be cyclic group? If it has at least one generator. Now let me find out at least one generator. If I could find out one generator, then I will say that it is cyclic group. Okay. Now 1 is identity element. It cannot be a generator here, especially with respect to multiplication, because any number of times you raise 1 to the power something, you will still be getting 1. 2. Let's see if 2 can be a generator or not. So how can we find out if 2 can be a generator? You have to find out 2 power 1 is 2, right? What about 2 power 2? 2 power 2 is 4. So 4 mod 7 is 4 itself. What about 2 power 3? So 2 power 3 is nothing but 4 into 2. 4 into 2 is 8. 8 mod 7 is 1, right? And if you remember, there was a point that every generator, order of every generator will be order of the group, which means if this would have been a generator, then the order of this element should have been 6. But 2 power 3, since it is 1, it is not a generator. Got it? If you remember it, order of a generator is equal to order of the group, which is nothing but 2 power number of elements in the group should be equal to 1 in case if 2 would have been a generator. But since it is not a generator, right, if we are getting 2 power 3 equal to 1. Even if you want to go further and even test it, you can test it. See, now if you go for 2 power 4, you can write it as if it is 2 power 3 into 2 power 1, which is again a 2, right? And again if you write 2 power 5, you can write it as 2 power 3 into 2 power 2, which is again 4. And 2 power 6, you can write it as 2 power 3 into 2 power 3, which is again 1. So you will not be generating all the elements, you will be generating only 2 4 1, and this cycle will repeat. Got it? So 2 cannot be a generator. What about 3? Can 3 be a generator? Let's check this. So 2 is not a generator. Can 3 be a generator? Let's check this. So 3 power 1 is 3. 3 power 2 is 9, therefore 2, because we are talking about mod 7. And 3 power 3 is, you can write it this way, 3 power 2 into 3 mod 7, which is nothing but 2 into 3 mod 7, right? So what is 2 into 3 mod 7? It is 6. Okay. And then 3 power 4 is, you can write it as if it is 3 square into 3 square. You can write any way, right? But then this multiplication is 3 power 7. So which is nothing but 4 here. And 3 power 5, you can write it as 3 power 2 into 3 power 3. This multiplication is mod 7 multiplication. And we know that 3 power 2 is 2 and 3 power 3 is 6. It is 12. And 12 means you are going to get 5 here. Isn't it? So when you divide 12 with 7, the remainder is going to be 5. and I think we got all of this, right? 3 power 6 is going to be 3 power 3 into 3 power 3, which is 6 into 6, which is nothing but 36 mod 7, which is 1. So we got all of them. So 3, 2, 4, 6, 4, 5, 1. So definitely 3 is a generator. Even if you see this, order of 3 is also order of the group. The reason is 3 power 6 we got as 6. So from this we can clearly say that 3 is a generator. Now you can, once you find out a generator, then you can declare that it is a cyclic group, and since it is a cyclic group, it is supposed to have 2 generators, and 2 generators are going to be a power 1 and a power 5, which means in this case if you substitute in place of a 3 power 1 and 3 power 5 are going to be generators, which means 3 power 1 is 3 and 3 power 5 is 5. So in this case 3 and 5 are 2 generators of this group. Got it? And you know, it is not just 3 power 1 and 3 power 5. You can even test for 5 power 1 and 5 power 5. Even if you go for 5 power 1 and 5 power 5, you will get the same thing. Got it? Okay. Now what about the next one? If you see this 1, 2, 3, 4, 5. So we have 0 to n minus 1, m minus 1, which means m elements are there. In this case 5 elements are there. So for these 5 elements we have to find out phi of 5. We are supposed to find out phi of 5. So what is phi of 5 here? In order to find it, you are supposed to find S5. So S5 is number of elements which are positive integers less than 5, which are relatively prime to 5. Since 5 is a prime number, 1, 2, 3, 4, all these will be relatively prime to 5. So how many elements are there? 4. So what does it mean? In case if this group happens to be a cyclic group, then the number of these generators are going to be 4, and if you can find out one generator, you can find out all the 4 generators. That is the concept. Okay, but then let's see if it can be a group or not. I think it is clearly a group. The reason is, if you see this 1 using 1, I think you can generate all the numbers. See this, 1 power 1 is going to be 1 power 2 is going to be 2. See, in this case it is addition modulo 5, which means 1 power 2 means it is not multiplication, it is addition, 1 plus 1, which is 2, and 1 power 3 is 1 plus 1 plus 1, which is 3, and 1 power 4 is 4, and 1 power 5 is 0, right? Why? Because it is 5 mod 5, which is 0. So we got all the numbers. Therefore definitely 1 is a generator, right? So 0 cannot be generated. I tested 1 and I got that 1 is a generator. Now once you get this, now we can find all the other 4 generators. See, we got that 0 is not a generator, and then since it is cyclic, it is supposed to have 4 generators. Therefore all the remaining 4 must be generators, or even if you can go with this method. So according to this method, according to this theorem, 1 power 1, 1 power 2, 1 power 3, 1 power 4, all these are going to be generators, which means 1, 2, 3, 4. These 4 are going to be generators. You can test it. Okay, you can test it yourself and you can see that these 4 are going to be generators. Now let's look at the next one. What about multiplication by 8? You see this, the number of elements in this one is 4, right? So what about phi of 4? See, you should not take phi of 8, phi of 5 or phi of 7. You should take the number of elements in this. That one you have to take 5. Now what about phi of 4? So phi of 4 is going to be, you have to find out S4. The number of elements less than 4 which are relatively prime to 4 is 1 and then 3. So 2. So what do you mean by that? So by this one we can understand that in case if this group is going to be cyclic, then the number of generators it will have is 2. Let's see whether it is going to be cyclic or not. Since it is multiplication operation, 1 cannot be generator. What is the reason? Even if you keep on multiplying 1 with itself, you will not get any different numbers, right? And what about 3? Let's test it. So 3 power 1 is 3, 3 power 2 is 1. So we directly got the generator. Now whatever you do, you will get only 3 and 1. Again, if you get 3 power 3, it is going to be 3. 3 power 4 is 1. So it cannot be a generator. What about 5? 5 power 1 is 5 and 5 power 2 is 25 and 1. So again here also we got directly the order of this element happened to be 2. If this had to be a generator, the order should be 4, but order is just 2, therefore it cannot be a generator. Same reason, right? Even if you repeat it, you will get 5 1, so you cannot get all the other elements. What about 7? 7 power 1 is 7 and 7 power 2 mod 8 is nothing but 49 means again 1. Again it is also, the order is 2, but if it had to be a generator, the order should have been 4. So there are no generators for this group. So what can you say? It is not cyclic group. So don't follow this, which means even though we are finding out this one, it is applicable only when it is a cyclic, but then it is not cyclic group. So one other way is, you can first find out whether it is cyclic group or not and then apply these rules. Okay, just for the practice sake I am doing this way. So you can find out whether it is a cyclic or not. In case if it is not cyclic, you can say that there are no generators at all. In case if you find a generator, you can find the other generators using this, right? So in this case G3 is not cyclic and so it cannot have any generators. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.